12点半才结束。
这个不是 double 吗？
那我解释了。
这是1楼啊。在这啊。看人家行路的，
还好，这种天气还好，不要下雨，就这种天气就好了。不然昨天那种天气很热，早上非常热，过中午就马上下雨，过中午马上下雨，就没地方走，就这样走到干嘛？刚好他们都进场了，其实他们进场就可以到。
演讲3分钟以前的而已。对哦，有这个。
阿玛尼，水哥。
他不是寿命快没了？
知道啊。
反正你一去也不补啊。
对啊。
还好，你妈不。
真的有那个人过来他们导演服务吗？有可能，我觉得对，还有要出来干嘛？我们也可以直接拍，但他们那边。
第一名mới。
对啊，所以我就穿了先套雨衣，怕我一个人来不及。暴雨，对啊，暴雨。我现在看一下，看什么？就开了。下午。这样就不会。 了解。
观众，飞达市长黄仁勋说，当然也是全球人工智慧产业的风向球。对上一次3国战略。
那我在这的时候，我呢？
今天会关注更新的相关产品，或是用更新的人工智慧的相关技能作为社会接下来的关注焦点。而且在黄仁勋这次来台湾的时候，询问他了辉达的海外总部究竟会设在台湾的什么地方呢？黄仁勋说，确实在台湾选址对他来说不容易，但他能知道说的内容这次的说这里很关心辉达的影响，所以那不是因为是否会来到台湾相关的。因为是另外一个主焦点，而且今天周末的时候，黄仁勋也请客宫殿举办了照片4个
他说要电子邮件信箱的那个地方，
所以你这个
对，不行，那就算了吧。
叫李哥传给你了。
NVIDIA 新多少？看到吗？实力基本看。好，它是一点场外的，因为我们现在是然后等下可能里面是一些通讯。
我们要看电邮的部分。我为什么什么小？
像到家里就可以。
还有这里可以传。老婆，你跟我拍一个。
还有分飞山，还有分座位啊。来，红哥，好不好？大概对，好的，那你email给我讲。OK， 好。啊 ，OK， 好，好吧。
哎，同学啊。
有什么没有啊？
你也是。
外面都没人赌，外面都只能做
9点半的，
大家都做 stand 而已，都没
9
人赌。
点半才能到，大部分到那个位置。可以。
K3媒体应该往这边。
はい。
可能吧？是吧？
可以拿2张。
啊，2张委员，对，好。不可能吗？怎么？我就不可能。谁你就谁。这个可以验证。他不是就是会在人家会场。
2甲。
没有那个证，因为我们那个。
来了。我来講。好。
对，他好像去报道。
你帮人家报道吗？一定要自己去，对不对？还是我们自己报？那就自己查就好。好好。报道完就有了。知道了，一张证，他中间有证。不要一张了。他叫我走过来拿给他。我走到前面来。
转场。
我已经走到前面来了。
刚刚有看到他，刚刚有看到他。
他有看到他跑去哪里？
不知道哎。 在已经结束哦，那对啊，没有啊，因为每个都然后我们家也知道他们报名。
你没报名就进不去啊？
对啊，我就在外面。
外面上班旁边有外机啊。
他也没给我那个扣。
他是有申请，我只是有申请，他申请到我才能进。一般不是我申请不能进去啊？对啊。
美国停在对面。
因为我们这跟你们后面一样。
才9点，其实还有2个小时。
好吧，我们这个人好就对。
哎，不用了，那个
刚拿过来，对，好，谢谢。 谁要扫？
你们要扫好，谁可以扫好？
国尾那个没有33对讯号。
要进去啊，待会去找那个大老板进去的，看在哪里。33 OK， 好，谢谢，拜拜。我看下船。
好，
啊，对啊。移到那边不太远，那这边
太晒了。
我们可以一起过去了。
好，我们要去哪一边？
去那个棚下就好了。
很重要吗？你要拍一张照片。
哎，是。
拍那个。
是。好了，要先吃。
那你可以帮我看一下吗？
我帮你手机啊，他的手机啊，没那个。
看看有家，手机放你这边，我们要过去赌。
这么好，还送手机啊？
好，那边，喂，手机给他了。
在我这。
没有。
笨友。
今天有没有准备东西？已经买周边了，是不是？
对，没错。
那可以跟大家讲一下买什么周边吗？
我买了他的帽子，对，然后还有杯子，对，因为我觉得很实用。
那有想要拿什么东西给我签名进去？
笔记本。或是等他的马克杯，我也想直接给他签。
多喜欢他，可以帮我们讲一下吗？把你的热情传达给他，他都会看新闻哦。
就是我现在也是工程师，然后我因为很欣赏就是 NVIDIA 这间公司，所以就是我也有去接有关 NVIDIA 的案子这样。对，然后我平常也都会就是看他的影片啊，跟就是访问这样。
那觉得他的个性怎么样？
我觉得很亲人，就是很亲近，很接地气。然后我有看，就是他可能他跟一些大佬聚餐出来，都会分一些食物给记者，就是很贴心。
那想要问一下这一位，
一样的，对，一样。
那有没有什么想要跟他表达的爱？
哦，没有，就我觉得他很酷，我就向他学习这样。对。今
天有买周边吗？
有一样。
是买一样的？
对，一样的。
那大家要给什么签名吗？
一样马克杯，对。
了解，谢谢两位，
谢谢，
拜拜。
来一包，你来一包。
你看那个后边的数字，好像那个什么 B，
我给。你要走进去，
去开吧。无另外一边。
看到我，他可能看到你的照片。
有，是要等一阵子才有。
手机蛮反光的，
还反光的。
你立一点好了。
啊，立一点。
对。
这样可以吗？
还是反光。
还是反光，好，那我遮一下。
有特别那个。
我有贴保护贴。
你可以帮我比一下那 QR code 吗？
这里。
对，在上面画一下没关系。OK， 谢谢。
不会。
所以我们在访问，我们在请你帮我们讲一次，觉得很早就什么时候报名的？
什么时候在报名？很早，我已经忘记什么时候。就是我一看到他有那个报名开放，我就报了。对。
怎么会那么早就报？而且刚好像说有点状况。
就是因为他好像要管制人流还是怎么样，所以他不是一报名就会得到 QR code， 他是后续才会寄发信件这样子。
那时候报名到的心情是怎么？
超开心，
就终于可以看到他本人。
对，很开心。
这样就可以。
谢谢，辛苦了，谢谢。
热，出现冰块。
有啊。
我们只能跟你们搭配车。
一个就第219B 那个。
我们也没有要单麦啊。
那个219B 那个包。
那你们没有报名？你们没有报名？
喂，那个。我刚第一个拍照，第一个拍照，
你跟我一起啊？
来，有啊，有啊。
可以。
开头了。
然后我们
以那个为背景，比较有报道的感觉。
对，我可以先问一下访问内容大概做什么？
就大概是今天来，然后什么时候报名的，然后怎么那么早来，就这样子，就一些比较。
OK，我觉得我应该不能接受这个访问。
真的吗？没关系，没关系，谢谢，谢谢。 好的，那你们直接来了。好，谢谢。A3。
那一台那什么那个特斯拉的修理车。
他们确定我们再过去就都来得及。
知啊？唔知，可能如果在这边捞。你也来捞了这个？不能啊！我想说带鸡我怎么捞？
是的，我们从日本。哦，日本来，我们跟你们做个简单访问好不好？然后我们
背在这边。
跟你们做个简单访问。
要不你访问他吧，他是我领导。
那我可能中文会比较适合。
哦，好。
你帮我讲一下，我们今天是我帮你拿就可以了。
好。
讲一下我们今天怎么那么早就来到现场，因为其实演讲11点才开始。
因为要先领那个叫什么通行证、识别证嘛，然后再加上据说这边会从9点半就有一个 NVIDIA 的那个什么介绍 video， 因为昨天收到那个邮件，然后就觉得还是要早点来，因为肯定很多人都是 Jason 的 fans， 对吧？肯定很多人排队，我们就早点来到这边。
我这次是特别来到台湾听。
对，我们专程从日本飞过来听。
怎么会这么喜欢 Jason， 或者有特别想要听到什么内容？
因为我们本来也是 engineer 这一方面，然后我们做的相关的，因为其实像芯片这边，NVIDIA 它整体的趋势，包括它现在的一个新的动向，都是我们非常关注的一个内容，所以我们肯定有新的动态，就希望第一时间都能捕捉到，然后可以获得一些最新的资讯，这样，所以就专程过来看有没有新的一些新的讯息啊之类的，可以 get 一下。
特别想要听到什么内
容？可能还是先再听一下，会不会有比如说 NVIDIA 它最新的一个近况的介绍呀，包括他们最新的 focus 的点呀，然后包括他们今后的一个计划和对之后整个行业趋势的一个愿景之类的，还是想再更新一下。
这样子就可以了，谢谢。
好，谢
谢。小姐贵姓？
哦，我是孙。
孙中山的孙。谢谢。
好，那我们要先给您签。
好，谢谢，感谢。
好，
谢谢。你们财经应该有人来啊，非凡的有人来啊，可是我们是不一样的公司啊，我们台式啊，他好像没在问，还是在忙别的，就是这样。因为这像我们都是做小的啊，对啊，不知道，不然如果有人这样搞这样，对，而且不见得说那个可以问到我。对啊，这个都要有专业来问，公司都觉得很轻松。有，我可能过来问怎么样问。有啊，人都係你我哋嚟啊，是啊，我哋搬來，你又來了，日本啊，你不來？他聽那個口音是大陸，應該在大陸上課。對啊，大陸口音啊。我知啊，我有看到啊。对啊，但目前没有什么。我记得了，就那一天我去香港机场，接黄仁勋的时候，他们帮我拿到那个。喂，你好，没有，我在等，我们在访，他应该是在里面，他不会在外面。我们刚刚在访问一些那个民众，一些他，我 就现在就看那个
你的台式是真麦还是假麦？假麦。那你的麦给他拿就好了。等下可以，现在是要做 stand 还是要做访问？
先访问好。
那可以一起问。那你的麦给我，你假麦放着就好，你的麦拿出来就好。所以先捞访问啊。喂。哎，怎样？排队已经没有排队的人潮，他已经开放进场，他现在都已经清空进去了。对，然后我现在就是帮忙于田说帮他捞几访问。好，拜。
中年娱乐啊，
吹舞了对哦。
迄个是迄个 YT 啊，YT要捞不好捞。
还要约你们来。过来。
找到做房子的要做
还有录到啊？还有录到啊？日本来的。他刚好日本来，你读到跟日本来的。以背景的，你这边为背景的。
这边来捞比较快。
我们是背景的，然后我们的，哎呀。
对啊。
他从澳洲来的，
哎，大哥，可以来，就是你是从澳洲来的吗？来，
我们那边背景我这边好不好？
好，今天从哪边过来的？
从澳洲雪梨。
哇，从这么远过来哦。
是。
那今天是从哪边得知消息？然后
从网络啊，现在很方便，就刚好我们也休假回来，所以带着小孩，他是读这相关的科系，带他来知道一些新的趋势，这样子。
比较希望可以听到什么样的分享？
当然就新的科技趋势的分享 ，AI 啊，对我们比较希望从他的身上看到未来有什么可以让我们更好的地方，这样子。
你分享一下心情。
很开心，对，谢谢。
谢谢。
要不要请你儿子一起过来？
我儿子啊。
那你们什么时候从澳洲过来？这几天。
对，因为他们大学他们读电机系嘛，所以他们的都相关的。
这几天提早到台湾来了。
对，就特别带他来一起看看这样子，谢谢。
那位帅哥是你儿子？对。
今天会议过了，姓赖先生，谢谢。
姓赖，谢谢。
Okay. Hi, just share your thoughts or your view, like why you're attending today.
Oh, I think NVIDIA is the top trend in the world, so everybody is crazy about AI, and I think AI is a new reality, so everyone wants to know about it, including myself. Yeah.
Where are you from?
I'm from Pakistan, but I live in Taiwan for 20 years, and also in US. Yeah.
Do you expect to hear NVIDIA CEO Jensen Huang say something?
Pardon me?
Are you expecting Jensen Huang to say something?
I think probably he will going to announce new applications today, and hopefully make the AI more common for all the people. Yeah.
Thank you.
Thank you. Thank you.
好，基辛港现在在战乱。
然后他本来就是台湾。
OK， 好，谢谢，
谢谢。
我们做实验不用拿2支哦。
还有假的，还有假的。OK。比较好吧？
拿去拿，就有人要捞，应该是够。
往右手边，对，右手边。
所以你们等一下可以进去的哦。
没进去啊。
哦。
我们还有个位置啊。
我们不行，我们那个位置。我这边只有在外面。
座位好像有衣服啊。是哦。对，这样拿去成公路啊，我都。有啊，里面就是里面的QR code。
我们要变。你好。Please in your email, not pictures. 没有网络连线吗？我这边是上午这边。
说到我们再过去。先不用。
怎么想要过来这边来看这样子？
来看这样子，好。
是他的员工吗？还是说是粉丝？
没有，我也是，其实也是媒体啊，对。
媒体，
对对，
理解，就是自己报名的。
对。
是平常是跑科技线。
对，就主要是看科技车用晶片的部分。对。
有觉得他今天可能会公布哪一些内容？
今天可能主要还是公布自己的伺服器之类的一些眼镜了，对。另外一部分可能大家比较关注的是说，辉达在台北的选址的地区会在哪？对。
那今天的话，有没有觉得这个动线感觉上怎么样？
目前看起来就是动线安排蛮好的，对，
都还 OK。
对，人潮也蛮多那样，
所以很早就开始报名。
对，就大概4月就已经开始报名了，对。
就自己是算自媒体吗？还是说？
是科技媒体。对。OK，
好，谢谢。
海鲜贵姓？余天的余。对，谢谢。
来问说你们今天怎么会想要过来？是他的粉丝还是员工吗？
没有，就是相关产业的，就是工作人员，都是做电脑的啦，电脑行业的。然后就
大家有多早就开始报名了？
多早
？1-2个礼拜前。
1-2个礼拜前吗？
就开始。
对。
今天有希望听到什么内容吗？
听到什么内容哦？就听到辉达落脚在哪里哦？
是要去买房吗？
希望啊。谢谢。
就是想问一下，今天的话，你们从哪边过来？
我们从新庄啊，对，新庄跟三重，对。
动线怎么样？
算是比较好，就没有到，因为 COMPUTEX 还没开始，可能人流没有那么多，对。就今天搭高铁、搭捷运都还算舒服，这样。
还 OK。
对。
再跟聊一下，你们觉得说今天的话，有没有期待 Jensen 他可能平常你就有关注吗？
有。是，其实像去年的那个完整的我也都有看完，然后像是我觉得刚刚来其实蛮兴奋的，因为它包含前面还有卖周边什么的，我觉得哇，不只是好像可以，其实也蛮期待听到，比如说看有没有机器人可以向量之类的。对。
好像周边有去买吗？
没有，刚刚还蛮多人的，想说待会可以去看一看。对。
谢谢你们。
谢谢。
也是给了我语言。对啊，3年平也利用他妈已经有母语，看状况嘛。是啊，又不是像那个白沙屯对我来汉族。这边乱呀，那会不会很要多点？我来问看有没有一款。应该都有了。他那个不能吃的。也有。
只有那个它的位置，就是有的
没去的基本上现在应该都是。
你们就是在第一排当。
这里来吗？
那我们可以投什么？
我们可以进去，然后那个他比较这种同事帮我排队开始做广告，多少啊？就等于结束了。很快来出来就一些那个新款的，对啊，现在有这个，那我们就可以进去了。这个链。
对。
日本的人。
不好意思，要陪你哦。你没有。
我跑到那边去了。算了。
不要了吗？不要了。
不要了。
日本人。
对啊，他刚刚讲就是。算了。
我们的支援要从南港展传过来。
哦，真的。
那边有个群众记者会结束。
这边走，谢谢。
我来拿。对，我们要进去了。往去哪了？待会再。我们要先出去，我们都是有位置哦。我们先去那个黑厅那边。
等一下，可是还是要再从那边排队。从后面这个，对。因为还是要。OK， 没问题，没问题，没问题。They already did it. That's okay. With the data and Sorry, can I check with you again for the registration? 早安。然后再来关节，你包包拿下来哦。对，你然后包包先放，然后再过来搞。好。东西包包先放着，然后手机都拿出来哦。谢谢。谢谢。好，直接过安全门就好。你身上还有其他的手机吗？手机。哦 ，OK， 手机是要拿下来的。好 ，OK， 谢谢。从哪里拉开？那就请问一下。你身上还有其他的？好，可以了。好，那机壳。哦，手机好像不行。OK， 这样是可以的。对，因为它有金属，它会讲。
哪个方向走？要音乐。好，就出来了。还有麦克啊？好麦克啊？哎对，麦克我好屌啊！我这样。Sorry.
So it's vision-based robot. Could you tell us about what the role you see the TakeMan play in the next wave of intelligence manufacturing, especially in Taiwan, and any practical example use case you can share with us?
Yes, actually, we start automotive around 13 years ago, and actually coupled with I'm a neighbor now, you know. So in the beginning, CTV capabilities not not just provide is that you? Exactly, like send it all over the CTV and it's massive.
You might be on the other side.
So in this time,
it's actually
we provide
expensive, but it's like way better.
Robot, correct robot for our customer. The differentiation compared with industrial robot is the gap. So because traditional robot, what they have, the sensing only the motor angle. They have in traditional robot because just they do some movement. 1 point is 1 point. So the computing power for the robot just
45分之后不能用无线。
only
好，
system
然后如果你们要说的话，就可以查
so
有
the
线。
computing
OK， 好，
is but one.
就是包可以接那边嘛？哦，对对对。
The intelligent car, the vision is most important for the robot.
那我们正在演，我们准备，那你
We can understand the environment, we can reasoning, planning, what we would like to do. That's why we have this capability. Most important is the vision. So 30 years ago, we think it's must have. If we compare the worldwide, I think we are very few companies is also vision is viewed in our robot. So in that timing, so we that's around few years we cooperate with Taiwan also manufacturer company. Yeah, for example, semiconductor and electronics, even CNC machinery, those of manufacturing. And what they need is intelligent solution for them. Why they need the intelligence? Because if we just take one object from one point to another point, like the brain work to do these things. But we have the vision. So in there, for example, for CNC, in their production, they have to come, the object don't need to fix in one precise position because our vision shooting position compensate the variation and the pick and after process. And we also can check the quality, maybe some scratch or the AI function we are run. For sure, we also use correct the robot industrial under control box. We implemented NVIDIA GPU side, so we can do AI inference. So like an edge computing.
I see. So that means the robot can do the calculation by itself, and also can recognize the image, and also can make some intelligence movement by itself, right?
Yes.
And with the box is not below, embedded with the NVIDIA GPU, you can do some high level language model or something.
Yes.
Yeah. The thing you bring the robot, is that the real robot or just the?
Sure, it's a toy, but it's our the technology. Yeah, I think it's easy for.
I understand.
You understand the difference because you can see yeah.
Well, thanks. Hey, Peter, can you talk about your collaboration between Delta and NVIDIA and maybe focus on the integration of your D-Bot series of robots with NVIDIA's Omniverse?
Sure, of course. Actually, we are producing a lot of products for the of course, and we are building the power modules for the data centers related. But our production line didn't really.
为什么你配这个？陈小姐，
带你们都大哥带我去买。
谢谢大哥，谢谢大哥，谢谢大哥。
We have the chance to cooperate with NVIDIA based on the Omniverse and combine with our we call machine and robot tool that can based on our edge computing, connecting our machine and robot immediately, real time, return the necessary critical packages and back to remote. For example, our production line in Thailand, in somewhere else in the world, we can remote monitor, measure, and even calculate that Dr. mentioned, the robotics, while the machine has some strange things happen, we can remote calculate based on the Omniverse, thanks to the Omniverse. And we have the beginning from the real to sim. We have real production line, but together with Omniverse, it becomes better. And that is not enough. People need, we have much more, we need to have much more production. Productivity.
要跟督访讲完而已。那可以出去吗？水可以喝吗？对，场外那边。
From our side,
we need to be balanced.
你们没有那个媒体那个休息的那个？有的 press room。对，等一下那个 keynote 开始之后会开放。 在这个门出去之后，会看到那个绿色墙。
So we also cooperate with our Omniverse to do the virtual design, even from the very beginning of the product design, and then later on for the related machine robotics, together with the necessary process technology to make the products correct and make the customer satisfied. So based on Omniverse, again, we do from sim to real. That means we don't need to really build production line so soon, but we can make sure everything that almost like the reality and minimize the trial. So we cooperate with NVIDIA so closely from real to sim and sim to real. So this is what we have done, and we will continue to do not only for the robots, the machine, process, the whole production line. And actually, this afternoon we will show the whole factory's simulation as well.
Thanks. Well, yeah, great to see. I mean, you're a company that we look at, very closely from your work with iPhones, smartphones, everything. But this robotics is really amazing. I think it needs more coverage. I was wondering, how did FII and NVIDIA first start working together and collaborating?
Okay. So probably people know we are running lots of manufacturing for the electronics. So we have more than the entire Foxconn group has more than 200. So just like what Jason mentioned,
Still not a lot.
AI, from sheet AI to generative AI to synthetic AI, even up to physical AI. We gradually follow on this. So back to 2016, we built the HPC as a media solution for medical research. We do not only make the smart manufacturing, but also medical research to help facilitate like
先拿衣服就好。
the first two we engage with media. Okay, only some people know that we have a very big embassy. We will produce electronics we manage the machine learning and start to use the tools. Back to 2003, when Gen AI was good. So we start to look at that, how to leverage the rapids under the ISA. So, the capacity of material moving on the workshop is very complicated. So how you can use AI? So we can train the AI model to move the material.
没有，他没有先位置啊，就拿一件走啊。对啊，可以啊，拿我拿了。对啊。
to the AGV, to the AMO.
媒体室。
不是要带我们去？
对啊。
媒体室。
我们先放东西而已。先放东西而已，嘿。
我们放着那个。
我可能要问一下。
先问一下，
好不好？哎呀。 你先把它收起来吧。看看后面也不会坐满的，你可以按 K2 好像都给媒体的。要不然我们先放外面那边，我们待会堵嘛。那情况的话，慢慢点。
你们要问什么？
要问讲啊。
对啊，我知道你要。
大家都会问。
大家都应该问啊。还是我们先放旁边这边就好了。
放旁边。
或者是妹妹你把它出去。对啊。
美美，我好感动。
喂，你先回去了哈。
请稍等一下，我们确认中。不好意思，
没听过，不然我们先放。
因为我们把东西先放着，我们还有另外。
我们放讲话呢？对，还是放市长？市长。
所以你们蹲一下是先放这里吗？还是？
放这里吗？
有没有什么地方可以站？
因为他们现在正在确认说能不能挪进去了，等我一下好吗？不好意思啊，抱歉，好，等我一下。
好，
马上好。
对，在那细在位。 有卡给没给啊？
这边到外面去，在这里面那边，因为两个温差太大。
对，我来换他们那家是哪一家？
天哪！好，我这个
我叫读法。
我跟你讲，我这个场面有更高有谁会这样临时？有啊，应该会吧？我在猜。
他从哪边进来不知道啊？
我也不知道，他肯定有秘密通道。我现在要连个线。
好，连个线 ，OK， 好。好，
没关系的，我们先看他可以。
等他一下啊！如果他不行，我就帮你们看。
对啊，没关系啊，摆的不会有那个。
我们找一个，我们放这边，他帮我们呼叫，进去啊。
好啊，是可以进去吗？
目前还不行。
那我们把东西看哪边，我们可以先暂时。
这边可以放吗？
路口不要挡到就好。
好 ，OK， 好。
可以让这个让给我。
好 ，OK， 好，谢谢，不好意思。
有人过号？
有。
先摆这边吗？摆这边就好了，那边不要挡。可以啊，没关系的。
马上我回来付了，反正我们不用。
OK， 好，
那可以了，就摆在这边。
好，谢谢哦。
加油。上面印有台北151，而另外呢这一栋建筑物呢，
好，那边。号码，我们这样这边走，就可以看。你说爱赌，对，爱赌呢，你妈要不要去啊？没有票，因为他们这边的出入口我们都可以看到。你说我号让我赌，好多人赌。外面开。对啊。好，知道了。去上个厕所。好，你那走。我就要比好了。你那带我出去比啊。
女生友善，
男生也可以，男生是前面一点啊，这友善你过来啊，嘛会使亲烟啦。
这嘛使用哪个？
嘿啦，友善的嘛使烟啦。嘿啦。
要出去外面。
嘿啊，这两间友善拢会使烟啦。
后门。号码。那个我们出去啊，那个，谢谢哦。来购物啊！
一下。
黄仁勋也相信按两百里啊。
对啊，
所以他们讲说从270那边进，路口就不知道了。
那有可能会从那边进去。
对啊，那怎么还好？
就往那边好了。
直接进去。
知道啊，我们也不知道，但我觉得他一定要走中间，他就想大家来，他一定不会躲躲藏藏。而且辉达也不知道还有。可是刚刚有些大佬想被拍了。
好，再见。再加吧。好，我进来我等。
好，辉达请小黄人请演讲室。好，辉达请小黄人请演讲室。
拆线时的话
讲完了。几点了？啊？不晓得啊。稍早是有人到澳洲来，看你要不要我在那 SD 卡给他套。
好啊。
因为还是我等下去里面，他开始你们里面有人进去吗？
里面有那个阿宝。
你要那个33度可以停哦。
对。学长呢？来打，看不见了。记得给白色。我觉得很慢。哦，离你完全没到。
哇，上次不是遇到？
哦，对。但我以前要记得，一定没消息。
今天快点做到睡着。
没有没意思。
早睡着。站在那边啊。现在冷气会一直换。对。那边。
我来问一下图摄影官。 我来问图哥。你去啊啦？
你去啊？
好啊。
那应该走那个后舞台进去了，对不对？
你有来那个北流吗？你有来北流吗？北流。OK， 好 ，OK， 好。他现在不在北流啊？对啊。北流了啦，现在是在北流了。我现在跟我先刚刚干嘛 ？OK， 谢谢，好，谢谢，好啊，好啊。
你去啊？
你去啊，换人啊。我啊。我怎么办？我去了外面的人。
进去。
喂，他进去了啦。
然后敏哥呢？
我啊。进去了。怎么办？
你有来？
这可以进去啊。
跟你老板来北流啊？
这个是他在场后面。
这个今天他没有来，没有来。
他在OK， 好。
好，谢谢你。拜拜。那这个不公开。对啊。
讲完进去了。好，那然后你好，我们进去了。3点多进了，下午1点半，也许2点半，我们应该准备要放出来。
喂，今天那个蒋万安已经到里面了，所以我们再进去喽。
对啊。
这个包包都在里面。
那给人家他管理和平公园。好 ，OK，
我刚独角飞连线，对吧？那个安全画面给他，那个就那个什么那个一样是原本你看站的舞台那个。
好，走啊。
那给都放在那个什么那个。过一下，谢谢。你好，我摸一下。
要那个报道好吧？
再上这边。
那我们再进去一下了。
我们要注意看啊，等下被炸啊，看到炸啊，注意。
他应该走后来了。
好，直接帮我进场哦，谢谢哦。
好，很多事情报告。
你刚刚又出
对啊，我们刚刚又出来了。
那你今天帮我们放一下。
我还是要看一下。
好的。
对，不好意思。
没关系。
啊。
对，还是看一下，对，应该是钥匙啦，对，钥匙和手表护照。
他进去了。
谢谢，好，谢谢。
他从后面一直在那走进去了，后门进去了。然后呢，他从爱讲带包爱藏内底啊，
包放在外面就好了。
啊？包放外面就好，他都不能拍，他关起来，他就接信号了。
哦，是哦。
对啊，他可以进去啊。
没有啦，是有线的，无线拍的。
先买，对，你先买。哦。
我先买。
谢谢。要进去了吗？好，那我们就进去，先来进去吧。谢谢。还在继续吗？我们先把那个包放进去，然后再进去。好。放这边就好了。摆那边好了。摆家吧，摆家吧，嘿呀。
有充电器，我真的太开心了。
好，行，你来。
啊，你们要回去？
没有，去里面。对，都听到。这边待会听到有。看那个电池够不够？够无？我睇 OK 你了。开啥？这一个。不够啊？没有够。够了，应该够。这。我来可以线麦，我来拿线麦，那我就接线麦就好了。好，你给咋的啊？那就他们那点的啊。啊。另外咋的啊？啊？我咋的啊？没有，炸就要碎掉。哦。买我买的吧？好，我现买袂记炸。那天去年我就忘记带。咱来坐车好啊。这里比较舒服。
高高的，对我们老人家来说。
好，脚套放那边就好了。可以。好，给他进去。进去。
你们先进去，我充个电。
拜拜呀。走。
到。
我有用他们的也很差，我用那种还没有答应。那我自己用麦抽吗？用麦刮什么抽啊？抽不到声音。用麦音很大的。哦。你是有电流的对不对？你可以看完有。你做电流的时候用。
还有电流声哦。啊？给他。给我听啊。
The birds are chirping, and the sun gonna shine. And I tell you one thing's been on my mind. This world we live in, well it's yours and mine. Let's make it brighter while we got time. We are people that make it happen. You and me just reach out and grab it. And I don't know what you've been told, but it's our time, yeah, it's our world. We're all people that make it happen. I see a difference, the day will come when all our troubles we've overcome. We climb the mountain just to see the sun. Ooh, transformation has just begun. We're all people that make it happen. You and me just reach out and grab it. I don't know what you've been told, but it's our time, yeah, it's our world. We're all people that make it happen. People that make it happen. You and me just reach out and grab it. And I don't know what you've been told, but it's our time, yeah, it's our world. We're all people that make it happen. We are people that make it happen. And me just reach out and grab it.
各位现场的来宾，请将您的行动装置关静音，我们的活动即将开始。
At this time, please take a moment to silence your devices. Our event is about to begin.
Run straight into the blackness. Let's preach some more practice. I'm addicted to the action. There's a big fever, I can feel it now. You keep on thinking you can wear me out, but I don't give in. I refuse. I won't let up. Nap outcast, to be the backlash of somebody's lack of love. Or you can start speaking up. Nothing's gonna hurt you the way the words do when they settle neath your skin. Kept on the inside and no sunlight. Sometimes a shadow wins. But I wonder what would happen if you say what you wanna say and let the words fall out. Honestly, I wanna see you be brave. What you wanna say and let the words fall out. Honestly, I wanna see you be brave. Just wanna see you. I just wanna see you. Just wanna see you. I wanna see you be brave. Just wanna see you. I just wanna see you. Just wanna see you. I wanna see you be brave. Everybody's been there, everybody's been stared down by the enemy, falling for the fear and about to disappear.
智慧就是这样制成的，一种新型的工厂，制造 tokens， 人工智慧的基石。tokens 开拓了一个新领域，带人们步入非凡世界，孕育无限的可能。tokens 将图像化为科学数据，描绘宇宙天文，引领未来的探索者。在地球上，它复印我们的城市，帮助我们克服今日的困难。tokens 揭发物理定律，让我们更快抵达目的地。并且不断向前。tokens 可以提前发现疾病的征兆，助我们揭开生命的奥秘。他们研究人体动作，协助我们达到最佳状态，还将现实带入虚拟世界。他们助我们精进技能。
有瑕疵的电路板在右边，需要我帮你拿去修理吗？好的，谢谢。
tokens 不仅教会机器人如何行动，还给世界带来欢乐。
请把这些送到护理站，
为我们提供助力。并让美好生活触手可及。让我们携手并进，勇敢探索人类未曾想象的可能。这一切都从这里开始。
女士们、先生们，欢迎 NVIDIA 创办人暨执行长黄仁勋先生。
Welcome to the stage, NVIDIA founder and CEO, Jensen Huang.
It's great to be here. My parents are also in the audience. 我爸爸妈妈来，他们在哪里？ They're up there. NVIDIA has been coming to Taiwan for over 30 years. This is the home of many of our treasured partners and dear friends. Over the years, you have seen NVIDIA grow up and seen us accomplish many exciting things and have been partnered with me all along the way. Today, we're going to talk about where we are in the industry, where we're going to go, announce some new products, exciting new products and surprising products that open new markets for us, creates new markets, new growth. We're going to talk about great partners and how we're going to develop this ecosystem together. As you know, we are at the epicenter of the computer ecosystem, one of the most important industries of the world. And so it stands to reason when new markets has to be created, we have to create it starting here at the center of the computer ecosystem. And I have some surprises for you, things that you probably wouldn't have guessed. And then, of course, I promise I'll talk about AI. And we'll talk about robotics. The NVIDIA story is the reinvention of the computer industry. In fact, the NVIDIA story is also the reinvention of our company. As I said, I've been coming here for 30 years. Many of you have been through many of my keynotes. Some of you, all of them. And just as you reflect on the conversation, the things we talked about in the last 30 years, how dramatically changed. We started out as a chip company with a goal of creating a new computing platform. And in 2006, we introduced CUDA, which has revolutionized how computing is done. In 2016, 10 years later, we realized that a new computing approach has arrived. And this new computing approach requires a reinvention of every single layer of the technology stack. The processor is new, the software stack is new, it stands to reason the system is new. And so we invented a new system that on the day I announced it at GTC 2006, no one understood what I was talking about and nobody gave me a PO. That system was called DGX-1. DGX-1, I donated the first one to a nonprofit company called OpenAI. And it started the AI revolution. Years later, we realized that in fact, this new way of doing software, which is now called artificial intelligence, is unlike traditional ways of running software. Whereas many applications ran on a few processors in a large data center, we call that hyperscale. This new type of application requires many processors working together, serving queries for millions of people. And that data center would be architected fundamentally different. We realized there were two types of networks. One for north-south, because you still have to control the storage, you still have to have a control plane, you still have to connect to the outside. But the most important network was going to be east-west. The computers talking to each other to try to solve a problem. We recognized the best networking company in east-west traffic for high-performance computing, large-scale distributed processing, a company that was very dear to our company and very close to our heart, a company called Mellanox, and we bought them 5 years ago, 2019. We converted an entire data center into one computing unit. And you heard me say before, the modern computer is an entire data center. The data center is a unit of computing. No longer just a PC, no longer just a server. The entire data center is running one job. And the operating system would change. NVIDIA's data center journey is now very well known. Over the last 3 years, you've seen some of the ideas that we're shaping and how we are starting to see our company differently. No company in history, surely no technology company in history, has ever revealed a roadmap for 5 years at a time. No one would tell you what is coming next. They keep it as a secret, extremely confidential. However, we realized that NVIDIA is not a technology company only anymore. In fact, we are an essential infrastructure company. And how can you plan your infrastructure, your land, your shell, your power, your electricity, all of the necessary financing around all over the world? How would you possibly do that if you didn't understand what I was going to make? And so we described our company's roadmap in fair detail, enough detail that everybody in the world can go off and start building data centers. We realize now we are an AI infrastructure company, an infrastructure company that's essential all around the world. Every region, every industry, every company will build these infrastructures. And what are these infrastructure? These infrastructure, in fact, not unlike the first industrial revolution, when people realized, GE, Westinghouse, Siemens, realized that there was a new type of technology called electricity, and new infrastructure has to be built all around the world. And these infrastructure became essential part of social infrastructure. That infrastructure is now called electricity. Years later, this is during all of our generation, we realized there was a new type of infrastructure. And this new infrastructure was very conceptual, very hard to understand. And this infrastructure called information. This information infrastructure, the first time it was described, made no sense to anybody. But we now realized it is the internet. And every internet is everywhere. And everything is connected to it. Well, there's a new infrastructure now. This new infrastructure is built on top of the first two. And this new infrastructure is an infrastructure of intelligence. I know that right now, when we say there's an intelligence infrastructure, it makes no sense. But I promise you, in 10 years' time, you will look back and you will realize that AI has now integrated into everything. And in fact, we need AI everywhere. And every region, every industry, every country, every company, all needs AI. AI has now part of infrastructure. And this infrastructure, just like the internet, just like electricity, needs factories. And these factories are essentially what we build today. They're not data centers of the past, a $1 trillion industry providing information and storage, supporting all of our ERP systems and our employees. That's a data center of the past. This is similar in the sense that it came from the same industry. It came from all of us, but it's going to emerge as something completely different, completely separated from the world's data center. And these AI data centers, if you will, are improperly described. They are, in fact, AI factories. You apply energy to it, and it produces something incredibly valuable. And these things are called tokens. To the point where companies are starting to talk about how many tokens they produced last quarter and how many tokens they produced last month. Very soon, we'll be talking about how many tokens we produce every hour, just as every single factory does. And so the world has fundamentally changed. We went from a company, on the day that we started our company, I was trying to figure out how big our opportunity was in 1993. And I came to the conclusion, NVIDIA's business opportunity was enormous. $300 million. We're gonna be rich. $300 million chip industry to a data center opportunity that represents about $1 trillion to now an AI factory, an AI infrastructure industry that will be measured in trillions of dollars. And this is the exciting future that we're undertaking. Now, at its core, everything we do is founded on several important technologies. Of course, I talk about accelerated computing a great deal. I talk about AI a great deal. What makes NVIDIA really special is the fusion of these capabilities. And very especially, the algorithms, the libraries, what we call the CUDA-X libraries. We're talking about libraries all the time. And in fact, we're the only technology company in the world that talks about libraries nonstop. And the reason for that is because libraries is at the core of everything that we do. Libraries is what started it all. And I'm going to show you a few new ones today. But before I do that, let me show you a preview of what I'm going to tell you today. Everything you're about to see is simulation, science, and artificial intelligence. Nothing you see here is art. It's all simulation. It just happens to be beautiful. Let's take a look. This is real-time computer graphics I'm standing in front of. This is not a video, this is computer graphics. It's generated by GeForce. This is a brand new GeForce 5060, RTX 5060. And this is from ASUS. My good friend Johnny is in the front row. And this is from MSI. And we took this incredible GPU and we shrunk it in here. Does that make any sense? See, this is incredible. And so this is MSI's new laptop with 5060 in it. GeForce brought CUDA to the world. Right now what you're seeing is every single pixel is ray traced. How is that possible that we're able to simulate photon and deliver this kind of frame rate at this resolution? Well, the reason for that is artificial intelligence. We're only rendering 1 out of 10 pixels. So every pixel that you see, only 1 out of 10 is actually computed. The other 9, AI guessed. Does that make any sense? And it's perfect. It's completely perfect. It guessed it perfectly. Of course, the technology is called DLSS, neural rendering. It took us many, many years to develop. We started developing it the moment we started working on AI, so it's been a 10-year journey. And the advance in computer graphics has been completely revolutionized by AI. GeForce brought AI to the world. Now AI came back and revolutionized GeForce. So really, really amazing. Ladies and gentlemen, GeForce. You know, when you're CEO, you have many children. And GeForce brought us here. And now, all of our keynotes is 90% not GeForce. But it's not because we don't love GeForce. GeForce RTX 50 series just had its most successful launch ever, the fastest launch in our history. And PC gaming is now 30 years old. So that tells you something about how incredible GeForce is. Let's talk about libraries. At the core, of course, everything starts with CUDA. And by making CUDA as performant as possible, as pervasive as possible, so that the installed base is all over the world, then applications can find a CUDA GPU quite easily. The larger the installed base, the more developers want to create libraries. The more libraries, more amazing things are done, better applications, more benefits to users, they buy more computers. The more computers, more CUDA. That feedback path is vitally important. However, accelerated computing is not general purpose computing. General purpose computing, write software, everybody writes it in, Python or C or C++, and you compile it. The methodology for general purpose computing is consistent throughout. Write the application, compile the application, run it on the CPU. However, that fundamentally doesn't work in accelerated computing, because if you could do that, it would be called a CPU. What's the point of not just changing the CPU so you could write the software, compile the software, run it on a CPU? The fact that you would have to do something different is actually quite sensible. And the reason for that is because so many people worked on general purpose computing, trillions of dollars of innovation. How is it possible that all of a sudden a few widgets inside a chip and all of a sudden computers become 50 times faster, 100 times faster? That makes no sense. And so the logic that we applied is that we could accelerate applications if you understood more about it. You can accelerate applications if you were to create an architecture that are better suited to accelerate, to run at the speed of light, 99% of the runtime, and just even though it's only 5% of the code, which is quite surprising. Most applications, small parts of the code consumes most of the runtime. We made that observation, and so we went after one domain after another. I just showed you computer graphics. We also have numerics. This is CuPy numeric. This is CuPy is the most pervasive numerical library. Arial and Shona. Arial is the world's first GPU accelerated radio signal processing for 5G and 6G. Once we make it software-defined, then we can put on top of it AI. So now we could bring AI to 5G and 6G. Parabricks for genomics analysis, Mo9 for medical imaging, Earth-2 for weather prediction, Quantum for quantum classical computer architectures and computer systems, equivariance and tensor, contraction of tensor mathematics, Megatron. This whole row, this whole column here consists of all of our deep learning and all of our libraries necessary for training as well as inference for deep learning. This revolutionized computing. And it all started with all these libraries. Not just CUDA, but cuDNN. On top of cuDNN, there was Megatron. Megatron, then TensorRT LLM, and then now lately, this brand new operating system for large AI factories, Dynamo. cuDF for data frames like Spark and SQL. Structured data can be accelerated as well. cuML, classical machine learning. Warp, a Pythonic framework for describing CUDA kernels, incredibly successful. cuOpt, mathematical operations, optimizations, things like traveling salesperson, the ability to optimize highly constrained, large number of variables, type of problems like supply chain optimization. This is an incredible success. I'm very excited about cuOpt, cuDSS and cuSparse for sparse structure simulators. Those are used for CAE and CAD, fluid dynamics, finite element analysis, incredibly important for EDAs and CAE industry. And then of course, cuLitho, one of the most important libraries for computational lithography. Mask making could easily take a month. And that mask making process is extremely computationally intensive. And now with cuLitho, we could accelerate that computation by 50 times, 70 times. As a result, this is going to set the stage, open the world for applying AI to lithography in the future. We have great partners here. TSMC is using cuLitho quite extensively. ASML, Synopsys, excellent partners working with us in cuLitho. So the libraries themselves is what makes it possible for us, one domain of application after another domain of science, after another domain of physics, to be able to accelerate those applications. But it also opens up markets for us. We look at particular regions and particular markets and we say, that area could really be important to transform to the new way of doing computing. If general purpose computing, after all these years, has run its course, why hasn't it run its course in every single industry? So one of the most important industries, of course, is telecommunications. Just as the world's cloud data centers have now become software-defined, it stands to reason that telecommunication should also be software-defined. And so that's the reason why we've taken now some 6 years to refine and optimize a fully accelerated radio access network, RAN stack, that does incredible performance. For data rate per megawatt, or data rate per watt, we are now on par with the state-of-the-art ASICs. And so once we could do that, once we could achieve that level of performance and functionality, then after that we can layer on top AI. And so we have great partners here. You could see SoftBank and T-Mobile, Indosat and Vodafone are doing trials. Nokia, Samsung, Kyocera are working with us on the full stack. Fujitsu and Cisco are working on the systems. And so now we have the ability to introduce the idea of AI on 5G or AI on 6G along with AI on computing. We're doing that with quantum computing. Quantum computing is still at the noisy intermediate scale quantum, called NISQ. However, there are many, many good applications we could already start to do. And so we're excited about that. We're working on a quantum classical or quantum GPU computing platform. We call it CUDA-Q, working with amazing companies around the world. GPUs could be used for pre-processing and post-processing, for error correction, for control. And so in the future, I predict that all supercomputers will have quantum accelerators, all have quantum QPUs connected to it. And so a supercomputer would be a QPU with QPUs and GPUs and some CPUs. And that would be the representation of a modern computer. So working with a lot of great companies in this area. AI. 12 years ago, we started with perception. AI models that can understand patterns, recognize speech, recognize images. That was the beginning. The last 5 years, we've been talking about generative AI, the ability for AI to not just understand, but to generate. And so it could generate from text to text. We use that all the time in ChatGPT. Text to images, text to video, video to text, images to text. Almost anything to anything, which is the really amazing thing about AI, that we've discovered a universal function approximator, a universal translator. It can translate from anything to anything else if we can simply tokenize it, represent the bits of information. Well, now we have reached a level of AI that's really important. Generative AI gave us one-shot AI. You give it text, and it gives you text back. That was 2 years ago when we first engaged ChatGPT. That was the big, amazing breakthrough. You give it text, and it gives you text back. It predicts the next word, predicts the next paragraph. However, intelligence is much more than just what you've learned from a lot of data that you've studied. Intelligence includes the ability to reason, to be able to solve problems that you've not seen before, to break it down step by step, to maybe apply some rules and theorems to solve a problem you've never seen, to be able to simulate multiple options and weigh its benefits. Some of the technology you might have heard about, chain of thought, breaking it down step by step, tree of thought, coming up a whole bunch of paths. All of these technologies are leading the ability for AI to be able to reason. Now, the amazing thing is, once you have the ability to reason, and you have the ability to perceive, that is, let's say, multimodal read PDFs, you could do search, you can use tools, you have now agentic AI. This agentic AI just does something that I've just described all of us do. We're given a goal, we break it down step by step, we reason about what to do, what's the best way to do it, we consider its consequences, and then we start executing the plan. The plan might include doing some research, might include doing some work, using some tools. It might include reaching out to another AI agent to collaborate with it. Agentic AI is basically understand, think, and act. Well, understand, think, and act is the robotics loop. Agentic AI is basically a robot in a digital form. These are going to be really important in the coming years. We're seeing enormous progress in this area. The next wave, beyond that, is physical AI. AI that understands the world. They understand things like inertia, friction, cause and effect. That if I roll a ball and it goes under a car, depending on the speed of the ball, it probably went to the other side of the car. But the ball did not disappear. Object permanence. You might be able to reason that if there's a table in front of you and you have to go to the other side, the best way to do it is not to go right through it. The best way is maybe go around it or underneath it. To be able to reason about these physical things is really essential to the next era of AI. We call that physical AI. And so in this particular case, you're seeing us simply prompt the AI, and it generates videos to train a self-driving car in different scenarios, and I'll show you more of that later. That's a dog. It said, generate me a dog, generate me one with a bird, with people. And it started out with the image on the left. And then the phase after that, we take reasoning systems, generative systems, physical AI, and this level of capability would now go into a physical embodiment we call a robot. If you could imagine that you can prompt an AI to generate a video to reach and pick up a bottle, of course you could imagine telling a robot to reach out and pick up the bottle. The AI capability today has the ability to do those things. Well, the computer that's where we're going in the near future. The computer that we're building to make this possible has properties that are very different than the previous. The revolutionary computer called Hopper came into the world about 3 years ago. And it revolutionized AI as we know it. It became probably the most popular, most well-known computer in the world. In the last several years, we've been working on a new computer to make it possible for us to do inference time scaling, or basically thinking incredibly fast. Because when you think, you're generating a lot of tokens in your head, if you will. You're generating a lot of thoughts, and you iterate in your brain before you produce the answer. So what used to be one-shot AI is now going to be thinking AI, reasoning AI, inference time scaling AI. And that's going to take a lot more computation. And so we created a new system called Grace Blackwell. Grace Blackwell does several things. It has the ability to scale up. Scale up means to turn what is a computer into a giant computer. Scale out is to take a computer and connect many of them together and let the work be done in many different computers. Scaling out is easy. Scaling up is incredibly hard. Building larger computers that is beyond the limits of semiconductor physics is insanely hard. And that's what Grace Blackwell does. Grace Blackwell broke just about everything. And all of you in the audience, many of you are partnering with us to build Grace Blackwell systems. I'm so happy to say that we're in full production, but we can also say it was incredibly challenging. Although the Blackwell systems based on HGX has been in full production since the end of last year and has been available since February, we are now just putting online all the Grace Blackwell systems. They're coming online all over the place every single day. It's available in CoreWeave now for several weeks. It's already being used by many CSPs. And now you're starting to see it coming up from everywhere. Everybody's starting to tweet out that Grace Blackwell is in full production. In Q3 of this year, just as I promised, every single year, we will increase the performance of our platform every single year like rhythm. And this year, in Q3, we'll upgrade to Grace Blackwell GB300. The GB300 will increase the same architecture, same physical footprint, same electrical and mechanicals, but the chips inside have been upgraded. It has upgraded with a new Blackwell chip, is now 1.5 times more inference performance, has 1.5 times more HBM memory, and it has 2 times more networking. And so the overall system performance is higher. Well, let's take a look at what's inside Grace Blackwell. Grace Blackwell starts with this compute node. This compute node right here, this is one of the compute nodes. This is what the last generation looks like, the B200. This is what B300 looks like. Notice right here in the center, it's 100% liquid cooled now, but otherwise, externally, it's the same. You could plug it into the same systems and same chassis. And so this is the Grace Blackwell GB300 system. It's 1.5 times more inference performance. The training performance is about the same, but the inference performance is 1.5 times more. Now this particular system here is 40 petaflops, which is approximately the performance of the Sierra supercomputer in 2018. The Sierra supercomputer has 18,000 GPUs, Volta GPUs. This one node here replaces that entire supercomputer. 4,000 times increase in performance in 6 years. That is extreme Moore's law. Remember, I've said before that AI, NVIDIA has been scaling computing by about 1 million times every 10 years. And we're still on that track. But the way to do that is not just to make the chips faster. There's only a limit to how fast you can make chips and how big you can make chips. In the case of Blackwell, we even connected 2 chips together to make it possible. TSMC worked with us to invent a new CoWoS process called CoWoS-L that made it possible for us to create these giant chips. But still, we want chips way bigger than that. And so we had to create what is called NVLink. This is the world's fastest switch. This NVLink here, right here, is 7.2 terabytes per second. 9 of these go into that rack. And that 9, those 9 switches are connected by this miracle. This is quite heavy. That's because I'm quite strong. I made it look so light, but this is 70 pounds. And so this is the NVLink spine. 2 miles of cables, 5,000 cables structured, all coaxed, impedance matched, and it connects all 72 GPUs to all of the other 72 GPUs across this network called NVLink switch. 130 terabytes per second of bandwidth across the NVLink spine. So just put in perspective, the peak traffic of the entire internet, is 900 terabits per second. Divide that by 8. This moves more traffic than the entire internet. 1 NVLink spine across this 9 of these NVLink switches, so that every single GPU can talk to every other GPU at exactly the same time. This is the miracle of GB200. And because there's a limit to how far you can drive SerDes, this is as far as any SerDes has ever driven. From chip, this goes chip to the switch, out to the spine, to any other switch, any other chip, all electrical. And so that limit caused us to put everything in one rack. And that one rack is 120 kilowatts, which is the reason why everything has to be liquid cooled. We now have the ability to disaggregate the GPUs out of one motherboard, essentially, across an entire rack. And so that entire rack is one motherboard. That's the miracle. Completely disaggregated, and now the GPU performance is incredible, the amount of memory is incredible, the networking bandwidth is incredible, and now we can really scale these out. Once we scale it up, then we can scale it out into large systems. And notice almost everything NVIDIA builds are gigantic. And the reason for that is because we're not building data centers and servers, we're building AI factories. This is CoreWeave. This is Oracle Cloud. The power density of each rack is so great, they have to put them further apart so that the power density could be distributed. But really, in the end, we're not building data centers, we're building AI factories. And this is the XAI, Colossus factory. This is Stargate, 4 million square feet, 4 million square feet, 1 gigawatt. And so just think about this factory here. This 1 gigawatt factory is probably going to be about, 60 to 80 billion dollars. Out of that 60 to 80 billion dollars, the electronics, the computing part of it, these systems are 40, 50 billion dollars of it. And so these are gigantic factory investments. The reason why people build factories is because you know the answer. The more you buy, say it with me. The more you buy, the more you make. That's what factories do. Okay. The technology is so complicated. And in fact, just looking at it here, you still cannot get the deep appreciation of the amazing work that's being done in all of our partners and all of the companies here in the audience in Taiwan. And so we made you a movie. I made you a movie. Take a look.
Blackwell is an engineering marvel. It begins as a blank silicon wafer at TSMC. Hundreds of chip processing and ultraviolet lithography steps build up each of the 200 billion transistors, layer by layer on a 12-inch wafer. The wafer is scribed into individual Blackwell die, tested and sorted. separating the good dies to move forward. The chip-on-wafer on substrate process, done at TSMC, SPIL, and Amkor, attaches 32 Blackwell dies and 128 HBM stacks on a custom silicon interposer wafer. Metal interconnect traces are etched directly into it, connecting Blackwell GPUs and HBM stacks into each system and package unit, locking everything into place. Then the assembly is baked, molded, and cured, creating the Blackwell B200 superchip. At KYEC, each Blackwell is stress tested in ovens at 125 degrees Celsius and pushed to its limits for several hours. Back at Foxconn, robots work around the clock to pick and place over 10,000 components onto the Grace Blackwell PCB. Meanwhile, additional components are being prepared at factories across the globe. Custom liquid cooling copper blocks from Cooler Master, AVC, Auras, and Delta keep the chips at optimal temperatures. At another Foxconn facility, ConnectX-7 SuperNICs are built to enable scale-out communications, and Bluefield 3 DPUs to offload and accelerate networking, storage, and security tasks. All these parts converge to be carefully integrated into GB200 compute trays. NVLink is the breakthrough high-speed link that NVIDIA invented to connect multiple GPUs and scale up into a massive virtual GPU. The NVLink switch tray is constructed with NVLink switch chips, providing 14.4 terabytes per second of all-to-all bandwidth. NVLink spines form a custom blind-mated backplane, integrating 5,000 copper cables to deliver 130 terabytes per second of all-to-all bandwidth. This connects all 72 Blackwells, or 144 GPU dies, into one giant GPU. From around the world, parts arrive. From Foxconn, Wistron, Quanta, Dell, Asus, Gigabyte, HPE, Supermicro, and other partners to be assembled by skilled technicians into a rack-scale AI supercomputer. In total, 1.2 million components, 2 miles of copper cable, 130 trillion transistors, weighing 1,800 kilograms. From the first transistor etched into a wafer to the last bolt fastening the Blackwell rack, every step carries the weight of our partners' dedication, precision, and craft. Blackwell is more than a technological wonder. It's a testament to the marvel of the Taiwan technology ecosystem. We couldn't be prouder of what we've achieved together. Thank you, Taiwan.
Thank you. Thank you. That was pretty incredible, right? But that was you. That was you. Thank you. Well, Taiwan doesn't just build supercomputers for the world. Today, I'm very happy to announce that we're also building AI for Taiwan. And so today we're announcing that Foxconn, Taiwan, the Taiwanese government, NVIDIA, TSMC, we're going to build the first giant AI supercomputer here for the AI infrastructure and the AI ecosystem of Taiwan. Thank you. Is there anybody who needs an AI computer? Any AI researchers in the audience? Every single student, every researcher, every scientist, every startup, every large established company, TSMC themselves does enormous amounts of AI and scientific research already. And so Foxconn does an enormous amount of work in robotics. I know that there are many other companies in the audience, I'm going to mention you in just a second, that are doing robotics research and AI research. And so having a world-class AI infrastructure here in Taiwan is really important. All of that is so that we could build a very large chip. And NVLink and Blackwell, this generation, made it possible for us to create these incredible systems. Here's one from Pegatron and QCT and Wistron and WeWin. This is from Foxconn and Gigabyte and ASUS. And you could see the front and the back of it. And its entire goal is to take these Blackwell chips that are, you could see how big they are, and turn it into one massive chip. Now, the ability to do that, of course, was made possible by NVLink. But it understates the complexity of the system architecture, the rich software ecosystem that connects it all together, the entire ecosystem of 150 companies that came together to build this. This architecture and the entire ecosystem in technology, in software, in industry has been the work of 3 years. This is a massive industrial investment. And now, we would like to make it possible for anybody who wants to build data centers. It could be a whole bunch of NVIDIA GB200s or 300s and accelerated computing systems from NVIDIA. It could be somebody else. And so today, we're announcing something very special. We're announcing NVIDIA NVLink Fusion. NVLink Fusion is so that you can build semi-custom AI infrastructure. Not just semi-custom chips, because those are the good old days. You want to build AI infrastructure. And everybody's AI infrastructure could be a little different. Some of you could have a lot more CPUs, and some of it could have a lot more NVIDIA GPUs, and some of it could be somebody's semi-custom ASICs. And those systems are so insanely hard to build. And they're all missing this one incredible ingredient. This incredible ingredient called NVLink. NVLink so that you could scale up these semi-custom systems and build really powerful computers. And so today we're announcing the NVLink Fusion. NVLink Fusion kind of works like this. This is the NVIDIA platform, 100% NVIDIA. You got NVIDIA CPU, NVIDIA GPU, the NVLink switches, the networking from NVIDIA called Spectrum X or InfiniBand, NICs, network interconnects, switches, and all of the entire system, the entire infrastructure built end-to-end. Now, of course, you can mix and match it if you like, and we now today make it possible for you to mix and match it even at the compute level. This would be what you would do using your custom ASIC. And we have great partners I'll announce in a second who are working with us to integrate your special TPU or your special ASIC, your special accelerator. And it doesn't have to be just a transformer accelerator, it could be an accelerator of any kind that you would like to integrate into a large scale-up system. We create an NVLink chiplet. It's basically a switch that abuts right up to your chip. There's IP that will be available to integrate into your semi-custom ASIC. And then once you do that, it fits right into the compute boards that I mentioned, and it fits into this ecosystem of an AI supercomputer that I've shown you. Now, maybe what you would like is you would like to use your own CPU. You've been building your own CPU for some time, and maybe your CPU has built a very large ecosystem, and you would like to integrate NVIDIA into your ecosystem. And now we make it possible for you to do that. You could do that by building a your custom CPU. We provide you with our NVLink chip-to-chip interface into your ASIC. We connect it with NVLink chiplets, and now it connects and directly abuts into the Blackwell chips and our next generation Rubin chips. And again, it fits right into this ecosystem. This incredible body of work now becomes flexible and open for everybody to integrate into. And so your AI infrastructure could have some NVIDIA, a lot of yours. A lot of yours, you know, and a lot of CPUs, a lot of ASICs, maybe a lot of NVIDIA GPUs as well. And so in any case, you have the benefit of using the NVLink infrastructure and the NVLink ecosystem, and it's connected perfectly to Spectrum X. And all of that, you know, is industrial strength and has the benefit of an enormous ecosystem of industrial partners who have already made it possible. So this is the NVLink Fusion. Whether you buy completely from us, that's fantastic. Nothing gives me more joy than when you buy everything from NVIDIA. I just want you guys to know that. But it gives me tremendous joy if you just buy something from NVIDIA. And so we have some great partners. L-Chip, Astera Labs, Marvell, and one of our great partners, MediaTek, are going to be partnering with us to work with ASIC or semi-custom customers, hyperscalers, who would like to build these things, or CPU vendors who would like to build these things, and they would be their semi-custom ASIC provider. We also have Fujitsu and Qualcomm who are building their CPUs with NVLink to integrate into our ecosystem. And Cadence and Synopsys, we've worked with them to transfer our IP to them so that they can work with all of you and make that IP available to all of your chips. So this ecosystem is incredible, but this just highlights the NVLink Fusion ecosystem. Once you work with them, you instantly get integrated into the entire larger NVIDIA ecosystem that makes it possible for you to scale up into these AI supercomputers. Now let me talk to you about some new product categories. As you know, I've shown you a couple of different computers. However, in order to serve the vast majority of the world, there are still some computers that are missing. And so I'm going to talk about them. But before I do that, I want to give you an update that, in fact, this new computer we call DGX Spark is in full production. DGX Spark will be ready, will be available shortly, probably in a few weeks. We have tremendous partners working with us: Dell, HPI, ASUS, MSI, Gigabyte, Lenovo. Incredible partners working with us. And this is the DGX Spark. This is actually a production unit. This is our version. However, our partners are building a whole bunch of different versions. This is designed for AI native developers. If you're a developer, you're a student, you're a researcher, and you don't want to keep opening up the cloud and getting it prepared, and then when you're done scrubbing it, okay? But you would just like to have your own, basically your own AI cloud sitting right next to you, and it's always on, always waiting for you. It allows you to do your prototyping, early development, and this is what's amazing. This is DGX Spark. It's 1 petaflops and 128 gigabytes. In 2016, when I delivered DGX1, this is just the bezel. I can't lift the whole computer. It's 300 pounds. This is DGX1. This is 1 petaflops and 128 gigabytes. Of course, this is 128 gigabytes of HBM memory, and this is 128 gigabytes of LPDDR5X. The performance is, in fact, quite similar. But what's most important is that the work that you could work on this is the same work you could do here. It's an incredible achievement over just the course of about 10 years. Okay, so this is DGX Spark for anybody who would like to have their own AI supercomputer. And it's, I'll let all of our partners price it for themselves, but one thing for sure, everybody can have one for Christmas. Okay. Okay, I've got another computer I want to show you. If that's not enough, and you would still like to have your own personal, thank you, Janine. This is Janine Paul, ladies and gentlemen. If that one isn't big enough for you, here's one. This is another desk side. This is also going to be available from Dell and HPI, ASUS, Gigabyte, MSI, Lenovo. It'll be available from Box, from Lambda, amazing workstation companies. And this is going to be your own personal DGX supercomputer. This computer is the most performance you can possibly get out of a wall socket. You could put this in your kitchen, but just barely. If you put this in your kitchen and then somebody runs the microwave, I think that's the limit. And so this is the limit. This is the limit of what you can get out of a wall outlet. And this is a DGX station. The programming model of this and the giant systems that I showed you are the same. That's the amazing thing. One architecture, and this has the ability, enough capacity and performance to run a 1 trillion parameter AI model. Remember, Llama is Llama 70B. A 1 trillion parameter model is going to run wonderfully on this machine. Okay, so that's the DGX station. So now let's talk about, remember these systems are, thank you, Jenny. These systems are AI natives. They're AI native computers. They're computers built for this new generation of software. It doesn't have to be x86 compatible. It doesn't have to run traditional IT software. It doesn't have to run hypervisors. It doesn't have to run it doesn't have to run Windows. These computers are designed for the modern AI native applications. Of course, these AI applications could be APIs that can be called upon by the traditional and the classical applications. But in order for us to bring AI into a new world, and this new world is enterprise IT, we have to go back to our roots, and we have to reinvent computing and bring AI into traditional enterprise computing. Now, enterprise computing, as we know, is really 3 layers. It's not just the computing layer. It's compute, storage, and networking. It's always compute, storage, and networking. And just as AI has changed everything, it stands to reason that AI must have changed compute, storage, and networking for enterprise IT as well. Well, that lower layer has to be completely reinvented, and we're in the process of doing that. I'm going to show you some new products that unlocks enterprise IT for us. It has to work with the traditional IT industry, and it has to add a new capability. And the new capability for enterprise is agentic AI. Basically, digital marketing campaign manager, a digital researcher, a digital software engineer, digital customer service, digital chip designer, digital supply chain manager, digital versions, AI versions of all of the work that we used to do. And as I mentioned earlier, agentic AI has the ability to reason, use tools, work with other AIs. So in a lot of ways, these are digital workers. They're digital employees. The world has a shortage of labor. We have a shortage of workers. By 2030, by about 30 to 50 million shortage. It's actually limiting the world's ability to grow. And so now we have these digital agents that can work with us. 100% of NVIDIA software engineers now have digital agents working with them so that they can help them, assist them in developing better code and more productively. And so in the future, you're going to have this layer, that's our vision. You're going to have a layer of agentic AIs, AI agents. And so what's going to happen to the world? What's going to happen to enterprise? Whereas we have HR for human workers, we're going to have IT becoming the HR of digital workers. And so we have to create the necessary tools for today's IT industry, today's IT workers, to be able to manage, improve, evaluate a whole family of AI agents that are working inside their company. And so that's the vision of what we want to build. But first, we have to reinvent computing. Remember what I said. Enterprise IT works on x86. It runs traditional software, such as hypervisors from VMware or IBM Red Hat or Nutanix. It runs a whole bunch of classical applications. And we need to have computers that do the same thing while it adds this new capability, called Agent AI. And so let's take a look at that. Okay, this is the brand new RTX Pro Enterprise and Omniverse server. This server can run everything. It has x86, of course. It can run all of the classical hypervisors. It runs Kubernetes in those hypervisors. So the way that your IT department wants to manage your network and how they want to manage your clusters and orchestrate workload works exactly the same way. It has the ability to even stream Citrix and what other virtual desktops to your PC. Everything that runs in the world today should run here. Omniverse runs on here perfectly. But in addition to that, this is the computer for enterprise AI agents. Those AI agents could be only text. Those AI agents could also be computer graphics. Little TJs, coming to you, little toy Jensens coming to see you, helping you do work. And so those AI agents could be either in text form, it could be in graphics form, it could be in video form. All of those workloads work on this system. No matter the modality, every single model that we know of in the world, every application that we know of should run on this. In fact, even Crysis works on here. Okay, so anybody who's a GeForce gamer? There are no GeForce gamer in the room. Okay, what connects these 8 GPUs, the new Blackwell RTX Pro 6000s, is this new motherboard. This new motherboard is actually a switched network. CX8 is a new category of chips. It's a switch first, networking chip second. It's also the most advanced networking chip in the world. This is now in volume production, CX8. In the CX8, you plug in the GPUs. The CX8s are in the back. PCI Express connected here. CX8 communicates between them. And the networking bandwidth is incredibly high at 800 gigabits per second. And this is the transceiver that plugs into here. So each one of these GPUs have their own networking interface. All of the GPUs are now communicating to all of the other GPUs on east-west traffic. Incredible performance. Now, the surprising part is this, how incredible it is. So this is RTX Pro. This is the performance, and I showed you guys at GTC how to think about performance in the world of AI factories. The way to think about this is throughput. This is tokens per second, which is the y-axis. The more output your factory, the more tokens you produce, okay? So throughput is measuring tokens per second. However, every AI model is not the same. And some AI models require much more reasoning. And so you need those AI models, you need the performance per user to be very high. So the tokens per second per user has to be high. And this is the problem with factories. Factories either like to have high throughput or low latency, but it doesn't like to have both. And so the challenge is how to create an operating system that allows us to have high throughput, the y-axis, while having very low latency, which is the y-axis, interactivity, tokens per second per user. And so this chart tells you something about the overall performance of the computer, of the overall computers of the factory. Look at all of those different colors. It represents the different ways you have to configure all of our GPUs to achieve the performance. Sometimes you need pipeline parallelism. Sometimes you want expert parallelism. Sometimes you want a batch. Sometimes you want to do speculative decoding. Sometimes you don't. And so all of those different types of algorithms have to be applied separately and differently depending on the workload. And the Pareto, the outside area, the overall area of that curve represent the capability of your factory, okay? And so notice something. Hopper is this is the most famous computer in the world, Hopper H100, the HGX, $225,000 Hopper is down there. And the Blackwell server you just saw, the enterprise server, is 1.7 times its performance. But this is amazing. This is Llama 70B. This is DeepSeek R1. DeepSeek R1 is 4 times. Now the reason for that, of course, the DeepSeek R1 has been optimized, and the DeepSeek R1 is genuinely a gift to the world's AI industry. The amount of computer science breakthrough is really quite significant and has really opened up a lot of great research for researchers in the United States and around the world. Everywhere I go, DeepSeek R1 has made a real impact on how people think about AI and how think about inference and how think about reasoning AIs. They've made a great contribution to the industry and to the world. And so this is DeepSeek R1. The performance is 4 times the state-of-the-art H100. That kind of puts it in perspective, okay? And so if you're building enterprise AI, we now have a great server for you. We now have a great system for you. It's a computer you could run anything on. It's a computer that has incredible performance. And it, whether it's x86 or AI, all of it runs. Okay, our RTX Pro server is in volume production across all of our partners in the industry. This is likely the largest go-to market of any system we have ever taken to market. So thank you very much. The compute platform is different. The storage platform is different. And the reason for that is because humans query structured databases like SQL. People query structured databases like SQL. But AI wants to query unstructured data. They want semantic, they want meaning. And so we have to create a new type of storage platform. And this is the NVIDIA AI Data Platform. On top, just as SQL servers, SQL software, and file storage software from your storage vendors that you work with, there's a layer of very complicated software that goes with storage. Most storage companies, as you know, is mostly a software company. That software layer is incredibly complicated. And so on top of a new type of storage system is going to be a new query system we call IQ, NVIDIA AIQ or IQ. And it's really state-of-the-art, it's fantastic. And working with basically everybody in the storage industry. Your future storage is no longer CPUs sitting on top of a rack of storage. It's going to be GPUs sitting on top of a rack of storage. And the reason for that is because you need the system to embed, find the meaning in the data, in the unstructured data, in the raw data. You have to index, you have to do the search, and you have to do the ranking. So that process is very compute intensive. And so most storage servers in the future will have a GPU computing node in front of it. It's based on the models that we create. Almost everything that I'm about to show you starts with great AI models. We create AI models. We put a lot of energy and technology into post-training of open AI models. We post-train these AI models with data that is completely transparent to you. It is safe and secure data, and it's completely okay to use to train, and we make that list available to you to see. And so it's completely transparent. We make the data available to you. We post-train the models, and our post-trained model performance is really incredible. It's right now, downloadable open source reasoning model. The Llama Nemotron reasoning model is the world's best. It's been downloaded tremendously. And also, we also surround it with a whole bunch of other AI models so that you can do what is called IQ, the retrieval part of it. It's 15 times faster than what's available out there, 50% better query results. And so these models are available, all available to you. The IQ blueprint are open source. And we work with the storage industry to integrate these models into their storage stack, their AI platform. This is VAST. This is what it looks like. I'm not going to go into it. I just want to give you a texture of the AI models that are integrated into their platform. Let's take a look at what VAST has done.
Agentic AI changes how businesses use data to make decisions. In just 3 days, VAST built a sales research AI agent using the NVIDIA IQ blueprint and its accelerated AI data platform. Using Nemo Retriever, the platform continuously extracts, embeds, and indexes data for fast semantic search. First, the agent drafts an outline, then taps into CRM systems, multimodal knowledge bases, and internal tools. Finally, it uses Llama Nematron to turn that outline into a step-by-step sales plan. Sales planning that took days now starts with an AI prompt and ends with a plan in minutes. With VAST's accelerated AI data platform, organizations can create specialized agents for every employee.
Okay, so that's VAST. Dell has a great AI platform, one of the world's leading storage vendors. Hitachi has a great AI platform, AI data platform. IBM is building an AI data platform with NVIDIA Nemo. NetApp is building an AI platform. As you could see, all of these are open to you. And if you're building an AI platform with a semantic query AI in front of it, NVIDIA Nemo is the world's best. Okay, so that gives you now compute for enterprise and storage for enterprise. The next part is a new layer of software called AI Ops. Just as supply chain has their ops and HR has their ops, in the future, IT will have AI ops. And they will curate data, they'll fine-tune the models, they'll evaluate the models, guardrail the models, secure the models, and we have a whole bunch of libraries of models necessary to integrate into the AI Ops ecosystem. We got great partners to help us do that, to take it to market for us. CrowdStrike is working with us. Data IQ is working with us. Data Robots is working with us. You can see these are all AI operations creating fine-tuning models and deploying models for agentic AI in enterprise. And you could see NVIDIA libraries and models integrated all over it. So Data Robots, here's Data Stacks. This is Elastic. I think I heard somewhere that they're downloaded 400 billion times. This is Nutanix. This is Red Hat. This is Trend Micro here in Taiwan. I think I saw Eva earlier. Okay, hi Eva. Okay, weights and biases. Okay, and so that's it. This is how we're going to bring the world and bring to the world's enterprise IT the ability to add AI to everything that you do. You're not going to rip out everything from IT, the enterprise IT organizations, because companies have to run. But we can add AI into it. And now we have systems that are enterprise ready with ecosystem partners, incredible ecosystem partners. I think I saw Jeff earlier. There's Jeff Clark, the great Jeff Clark. Been coming to Taiwan for as long as I have been coming to Taiwan, and has been a partner of all yours for a long time. So there's Jeff Clark. And so our ecosystem partners, Dell and others, are going to take this platform, these platforms, to the world's enterprise IT. Okay, let's talk about robots. So agentic AIs, AI agents, a lot of different ways to say it, agents are essentially digital robots. Reason for that is because a robot perceives, understands, and plans. And that's essentially what agents do. But we would like to build also physical robots. And these physical robots, first, it starts with the ability to learn to be a robot. The ability to learn to be a robot can't be done in the physical world productively. You have to create a virtual world where the robot can learn how to be a good robot. That virtual world has to obey the laws of physics. Most physics engines don't have the ability to, with fidelity, deal with rigid and soft body simulation. And so we partner with DeepMind, Google DeepMind, and Disney Research to build Newton, the world's most advanced physics engine. It's going to be open sourced in July. It's incredible what it can do. It's completely GPU accelerated. It's differentiable, so you could learn from experience. It is incredibly high fidelity. It's super real time. And so we could use that Newton engine, and it's integrated into Mujoko. It's integrated into NVIDIA's Isaac Sim. So irrespective of the simulation environment and framework you use. And so with that, we can bring these robots to life. Who doesn't want that? I want that. Can you imagine one of those little ones or a few of them running around the house, chasing your dogs, driving them crazy? And so, did you see what was happening? It wasn't an animation, it was a simulation. And he was slipping and sliding in the sand, in the dirt. All of it was simulated. The software of the robot is running in the simulation. And so it wasn't animated, it was simulated. And so in the future, we'll take the AI models that we train and we put it into that robot in simulation and let it learn how to be a great robot. Well, we're working on several things to help the robotics industry. Now, you know that we've been working in autonomous systems for some time. Our self-driving car basically has 3 systems. There's the system for creating the AI model, and that's GB200, GB300. It's going to be used for that, training the AI model. Then you have Omniverse for simulating the AI model. And then when you're done with that AI model, you put that model, the AI, into the self-driving car. Okay, this year we're deploying Mercedes around the world, our self-driving car stack, end-to-end stack. But we create all of this, and the way we go to market is exactly the same that we work everywhere else. We create the entire stack, we open the entire stack, and for our partners, they use whatever they want to use. They could use our computer and not our library. They could use our computer, our library, and also our runtime. However much you would like to use, it's up to you, because there's a lot of different engineering teams and different engineering styles and different engineering capabilities. We want to make sure that we provide our technology in a way that makes it as easy as possible for everybody to integrate NVIDIA's technology. You know, like I said, I love it if you buy everything from me, but just please buy something from me. Okay. Very practical. And so we're doing exactly the same thing in robotic systems, just like cars. And so this is our Isaac Groot platform. The simulation is exactly the same as Omniverse. The training system is the same. When you're done with the model, you put it inside this Isaac Group platform. And Isaac Group platform starts with a brand new computer called Jetson Thor. This is just started in production. It is an incredible processor. Basically, a robotic processor goes to self-driving cars, and it goes into a humanoid robotic system. On top is an operating system we call NVIDIA Isaac. The NVIDIA Isaac operating system is the runtime. It does all of the neural network processing, the sensor processing, pipelines all of it, and deliver actuated results. And then on top of it, pre-trained models that we created with an amazing robotics team that are pre-training these models. And all the tools necessary in creating this, we make available, including the model. And so today we're announcing that Isaac GR00T N1.5 is now open sourced. And it's open to the world to use. It's been downloaded 6,000 times already, and the popularity and the likes and the appreciation from the community is incredible. And so that's creating the model. We also open the way we created the model. The biggest challenge in robotics is, the biggest challenge in AI overall is, what is your data strategy? And your data strategy has to be, that's where a great deal of research and a great deal of technology goes into. In the case of robotics, human demonstration, just like we demonstrate to our children or a coach demonstrates to an athlete, you demonstrate using teleoperations. You demonstrate to the robot how to perform the task, and the robot can generalize from that demonstration, because AI can generalize and we have technology for generalization. You can generalize from that one demonstration other techniques, okay? And so what if you want to teach this robot a whole bunch of skills? How many different teleoperation people do you need? Well, it turns out to be a lot. And so what we decided to do was use AI to amplify the human demonstration systems. And so this is essentially going from real to real and using an AI to help us expand, amplify the amount of data that was collected during human demonstration to train an AI model. Let's take a look.
The age of generalist robotics has arrived, with breakthroughs in mechatronics, physical AI, and embedded computing. Just in time, as labor shortages limit worldwide industrial growth. A major challenge for robot makers is the lack of large-scale, real, and synthetic data to train models. Human demonstrations aren't scalable, limited by the number of hours in a day. Developers can use NVIDIA Cosmos Physical AI World Foundation models to amplify data. GR00T Dreams is a blueprint built on Cosmos for large-scale synthetic trajectory data generation, a reel-to-reel data workflow. First, developers fine-tune Cosmos with human demonstrations recorded by teleoperation of a single task in a single environment. Then, they prompt the model with an image and new instructions to generate dreams, or future world states. Cosmos is a generative model, so developers can prompt using new action words without having to capture new teleop data. Once a large number are generated, Cosmos reasons and evaluates the quality of each dream, selecting the best for training. But these dreams are still just pixels. Robots learn from actions. The GR00T Dreams blueprint generates 3D action trajectories from the 2D dream videos. This is then used to train the robot model. GR00T Dreams lets robots learn a huge variety of new actions with minimal manual captures. So a small team of human demonstrators can now do the work of thousands. GR00T Dreams brings developers another step closer to solving the robot data challenge.
Is that great? So in order for robotics to happen, you need AI. But in order to teach the AI, you need AI. And so this is really the great thing about the era of agents, where we need a large amount of synthetic data generation, robotics, a large amount of synthetic data generation, and skill learning called fine-tuning, which is a lot of reinforcement learning, and enormous amount of compute. And so this is a whole era where the training of these AI, the development of these AI, as well as the running of the AI needs an enormous amount of compute. Well, as I mentioned earlier, the world has a severe shortage of labor. And the reason why humanoid robotics is so important is because it is the only form of robot that can be deployed almost anywhere brownfield. It doesn't have to be greenfield. It could fit into the world we created. It could do the tasks that we made for ourselves. We engineered the world for ourselves, and now we could create a robot that fit into that world to help us. Now, the amazing thing about human robotics is not just the fact that if it worked, it could be quite versatile. It is likely the only robot that is likely to work. And the reason for that is because technology needs scale. Most of the robotic systems we've had so far are too low volume. And those low volume systems will never achieve the technology scale to get the flywheel going far enough, fast enough, so that we're willing to dedicate enough technology into it to make it better. But human or robot, it is likely to be the next multi-trillion-dollar industry. And the technology innovation is incredibly fast. And the consumption of computing and data centers, enormous. But this is one of those applications that needs 3 computers. One computer is an AI for learning. One computer is a simulation engine where the AI can learn how to be a robot in a virtual environment, and then also the deployment of it. Everything that moves will be robotic. As we put these robots into the factories, remember, the factories are also robotic. Today's factories are so incredibly complex. This is Delta's manufacturing line, and they're getting it ready for a robotic future. It is already robotics and software defined, and now in the future there will be robots working in it. In order for us to create robots and design robots that operate as a fleet, as a team, working together in a factory that is also robotic, we have to give it omniverse to learn how to work together. And that digital twin, you now have a digital twin of the robot, you have a digital twin of all of the equipment, you're going to have digital twin of the factory. Those nested digital twins are going to be part of what Omniverse is able to do. This is Delta's digital twin. This is WeWin's digital twin. Now, while you're looking at this, if you look at it too closely, you think that it's in fact photographs. These are all digital twins. They're all simulations. They just look beautiful. The image just looks beautiful, but they're all digital twins. This is Pegatron's digital twin. This is Foxconn's digital twin. This is Gigabyte's digital twin. This is Quanta's. This is Wistron's. TSMC is building a digital twin of their next fab. As we speak, there are $5 trillion of plants being planned around the world. Over the next 3 years, $5 trillion of new plants. Because the world is reshaping, because reindustrialization moving around the world, new plants are being built everywhere. This is an enormous opportunity for us to make sure that they build it well and cost effectively and on time. And so putting everything into a digital twin is really a great first step and preparing it for a robotic future. In fact, building that $5 trillion doesn't include a new type of factory that we're building. And even our own factories, we put in a digital twin. This is the NVIDIA AI factory in a digital twin. Kaohsiung is a digital twin. They made Kaohsiung a digital twin. There are already hundreds of thousands of buildings, millions of miles of roads. And so, yes, Kaohsiung is a digital twin. Let's take a look at all of this.
Taiwan is pioneering software-defined manufacturing. TSMC, Foxconn, Wistron, Pegatron, Delta Electronics, Quanta, WeWin, and Gigabyte are developing digital twins on NVIDIA Omniverse for every step of the manufacturing process. TSMC with MetAI generate 3D layouts of an entire fab from 2D CAD and develop AI tools on CUOPT that can simulate and optimize intricate piping systems across multiple floors, saving months of time. Quanta, Wistron, and Pegatron plan new facilities and production lines virtually prior to physical construction, saving millions in costs by reducing downtime. Pegatron simulates solder paste dispensing, reducing production defects. Quanta uses Siemens Teamcenter X with Omniverse to analyze and plan multi-step processes. Foxconn, Wistron, and Quanta simulate power and cooling efficiency of test data centers with Cadence Reality Digital Twin. And to develop physical AI-enabled robots, each company uses its digital twin as a robot gym to develop, train, test, and simulate robots. Whether manipulators, AMRs, humanoids, or vision AI agents as they perform their tasks, or work together as a diverse fleet. And when connected to the physical twin with IoT, each digital twin becomes a real-time interactive dashboard. Pegatron uses NVIDIA Metropolis to build AI agents who help employees learn complex techniques. Taiwan is even bringing digital twins to its cities. Linker Vision and the city of Kaohsiung use a digital twin to simulate the effects of unpredictable scenarios and build agents that monitor city camera streams, delivering instant alerts to first responders. The age of industrial AI is here, pioneered by the technology leaders of Taiwan, powered by Omniverse.
My entire keynote is your work. It's so excellent. Well, it stands to reason that Taiwan, at the center of the most advanced industry, the epicenter where AI and robotics is going to come from, it stands to reason that this is an extraordinary opportunity for Taiwan. This is also the largest electronics manufacturing region in the world. And so it stands to reason that AI and robotics will transform everything that we do. And so it's really quite extraordinary that for one of the first times in history that the work you do has revolutionized every industry, and now it's going to come back to revolutionize yours. At the beginning, I said that GeForce brought AI to the world, and then AI came back and transformed GeForce. You brought AI to the world. AI will now come back and transform everything that you do. It's been a great pleasure working with all of you. Thank you. I have a new product. I announced several products already today, but I have a new product to announce. We've been building out in Space Dock for some time. And I think it's time for us to reveal one of the largest products that we've ever built. And it's parked outside waiting for us. Let's see how it goes. NVIDIA Constellation. NVIDIA Constellation. Well, as you know, we have been growing. And all of our partnerships with you have been growing. The number of engineers we have here in Taiwan have been growing. And so we are growing beyond the limits of our current office. And so I'm going to build them a brand new NVIDIA Taiwan office, and it's called NVIDIA Constellation. We've also been selecting the sites. We've been selecting the sites, and all of the mayors and all the different cities have been very kind to us. And I think we got some nice deals. I'm not sure. It seems quite expensive. But prime real estate is prime real estate. And so today, I'm very pleased to announce that NVIDIA Constellation will be at Beitou Shiling. We have negotiated the transfer of the lease from the current owners of that lease. However, I understand that in order for the mayor to approve that lease, he wanted to know whether the people of Taipei approve of us building a large, beautiful NVIDIA Constellation here. Do you? He also asked for you to call him. And so I'm sure you know his numbers. Everybody call him right away. Tell him that you think it's a great idea. So this is going to be NVIDIA Constellation. We're going to build it. We're going to start building as soon as we can. We need the office space. NVIDIA Constellation, Beitou Shiling. Very exciting. Okay. Well, I want to thank all of you. I want to thank all of you for your partnership over the years. We are at a once-in-a-lifetime opportunity. It is not an understatement to say that the opportunity ahead of us is extraordinary. For the very first time in all of our time together, not only are we creating the next generation of IT, we've done that several times. From PC to internet to cloud to mobile cloud, we've done that several times. But this time, not only are we creating the next generation of IT, we are in fact creating a whole new industry. This whole new industry is going to expose us to giant opportunities ahead. I look forward to partnering with all of you on building AI factories, agents for enterprises, robots, all of you amazing partners building the ecosystem with us around one architecture. And so I want to thank all of you for coming today. Have a great COMPUTEX, everybody. 大家谢谢. Thank you. Thank you for coming. Thank you.
知道人家就问那个当时有刚弄吗？没有了，没有了，他说那个黄仁勋讲，他晚上去。那晚上没有。所以下午大家要。
啊？可以出手就这样。
啊，再来一个。
早，我还不知道他会不会停下来放。我就讲他那个昏倒。
那个白点那边啊，那边有一个白点我。那边啊，那边一个白点啊，油漆的白点，还是有油漆。你再往前走，啊，没有那边，你看那边那个点。看到吗？在这个时候，太小了。我说我不是给人吹的，我是要给机器吹的。你看那个荧幕有多大？
有文字啊，北斯科地点确切地点。另外一个啊，我家附近是生活帮。然后他说，李娟跟我们不会，应该是不会让大家。